Good morning, Algebra 2 class. This video today is talking about independent and dependent events. So your learning target is learning target 3I. I can find the probability of two or more independent or dependent events. Okay. So last time we talked about inclusive versus exclusive events, which is also compound probability. But in that instance, we were working with something that was only one action, right? So we rolled the die once and we wanted two outcomes. We wanted to roll a 5 or an even number. This time we're going to be doing at least two actions. So we're not just rolling a die once, we'd be rolling a die twice, or we'd be picking a card out of a deck once and then picking another one after that. So we're finding the probability of doing two or more separate events, finding the probability of two or more separate events, but we're also doing two or more separate actions to get those, okay? So for this probability, we're working with separate actions. So keep that in mind. It's not just one motion or one action, it's more than one. And we're gonna see the word and a lot, okay? So and in probability, we said or in probability means to add our probabilities together, and is going to tell us to multiply those probabilities together. So we'll still be finding probabilities separately, and then to get our total probability, we would multiply those values together, all right? And so you can think about when we're adding fractions, the denominator isn't going to change. So our probability was pretty high of, rolling a die once and getting a 2 or a 6, much higher than if we just wanted a 2. When we start to multiply, right, so if I was just adding, 1 6 plus 1 6, I get 2 6, or 1/3, which is 33%, right? If I were to multiply those together instead, we multiply straight across, we end up with 1/36. That percentage is much, much smaller than 1/3, or 33%. That would give us 2.8%, okay? So you should expect your probabilities to be a lot smaller here because it's much harder to do something in two separate actions and get exactly what you want than it is to just perform one action, just roll that die once and get multiple outcomes, okay? So we're hoping for, we're going to roll the die once and get what we want, and then we're going to roll the die again and get what we want. That's a lot harder to do than it is to say roll a die once and get something out of two options, right? So your probabilities are going to be a lot smaller here, just to keep that in mind. So let's check out an example and see if we can figure out what's the difference between independent and dependent variables. So just have a little clip here, the guy slipping on some marbles. Bonus points if you can figure out what that's from. And the example says, consider a bag of marbles here. So inside of this bag of marbles, there are 5 blue marbles, 3 red marbles, and 9 green marbles. They're all mixed together. We are being asked, what's the probability of reaching in to the bag, getting a blue marble, then we want to replace whatever marble we picked up, and then we're going to reach into the bag again for a red marble. And this word right here, this replace, becomes really, really, really important in this type of probability, and we'll look at that in just a sec. So when we do this type of probability, I've set it up down here. We want to find the probability of getting a blue, and then the probability of picking a red marble. So just like we did before, we're going to find the probability of those two things separately. So we're going to figure out, okay, what's the probability of me getting a blue marble? What's the probability of me getting a red marble? And then because it says and, because it's two separate actions, I am multiplying those together instead of adding them, okay? So first, let's think about the probability of me getting just a blue, all right? So this blue here. Well, how many blues are there? There are 5. Out of the total number of marbles would be 5 plus 3 plus 9. so 17. Okay, so my probability of just getting a blue marble when I reach to the bag is 5 out of 17, right? I took that blue marble, well, I'm assuming I got what I want when I do this probability. So I took that blue marble, put it back in the bag, shook them up, and then I reached in again and picked my second one, right? And I'm hoping for a red this time. So now I'm hoping to get a red marble. So when I reach into the bag, there are still 3 marbles in there, and there are still 17 total marbles because I put that first one back, right? I replaced it. So that's really important, right? You can think, if I didn't replace that first marble, if I kept it with me, there would not be 17 marbles in the bag anymore. There would only be 16, so it would be changing my probability for the second one. And that change is called a conditional probability, but we'll work more on that next time. So what I really needed to do was find the probability of a blue marble, probability of a red marble, and then we're going to multiply those two things together. So we multiply fractions straight across, so it would be 15, and then 17 times 17 is 289. And then to get the percentage, we're going to take that 15 divided by 289, and we get 0.0519. So that would be if I move the decimal point 2 places, or if I multiply by 100, I get 5.19 or 5.2%. All right. So the total here is 5.2%. So not a great chance of getting a blue marble first and then getting a red marble. All right. This probability that we just did is what we call independent probability. These two events were independent, okay? And so what that means is the probability of the first event did not affect the probability of the second event. Oh, sorry, I just sneezed. So what that really means here is that when we found the probability of getting a blue marble, it was 5 out of 17. And then because we replaced it, because we replaced that first one, we still had 17 marbles in the bag, right? So finding this second probability was just basic probability. It would be the same as if I said, hey, just find me the probability of picking a red marble. And we don't even have to care that something happened first. Something happened before that, right? So when I think independent probability, I'm always asking myself, did what I do first change the probability of what I'm doing second, right? So did me picking up a blue marble change the probability of then me picking up a red marble? In this case, no, because I put the marble back, right? So it's that idea of replacement that's so important here. That's what creates independent events, okay? Let's look at a second example, and hopefully this will help clarify that. So we have the same bag of marbles, 5 blues, 3 reds, 9 greens. This time we want the probability of reaching in for a blue, keeping the marble. So now I'm going to put that marble in my hand, I'm going to hold on to it, and then I'm going to reach in again for a green marble, all right? So it's the probability of a blue marble and a green marble. So again, going to find those both separately, and because it says and, we're dealing with multiplication. So to start off again, and we're assuming every time we start a new problem, we're starting over with the bag. So if I want the probability of a blue marble, there are still 5 blue marbles out of 17, right? So that first probability is just basic probability, hasn't changed. Now I'm going to multiply that by the probability of getting a green, but think about what happened this time. The blue marble that I picked, assuming I got what I want, I am keeping that in my hand, okay? I need that blue marble. So when I go in to reach for a green, again, assuming I got a blue, got what I want, there are 9 greens, but how many total marbles are in the bag right now? If I'm holding that blue one in my hand. Yeah, there are only 16, right? So the probability of this first thing, the probability of getting a blue, actually changed the probability of getting the green, right? Now the denominator is 16 and not 17. So that's the real difference here. That's what makes this not independent. Same multiplication process, we'd multiply straight across. So this time we have 45 over 17 times 16. Let's see what that is. 272. So 45 divided by 272 is 0.165 times 100 is 16.5%. All right, so we have a little bit of a better chance of getting a blue and a green than we did of getting a blue and a red. One of the reasons is because we didn't replace that first marble because we have fewer marbles in the bag to choose from. Our probability gets higher. The other reason is there were more green marbles, right? So a couple of reasons there. So 2 dependent events are when the probability of the first event like picking a blue marble and not replacing it, when the probability of the first event affects the probability of the second. Okay, and so this time a lot of this you'll see the words not replacing or keeping out or not putting back. That sort of phrasing there tells you that it's going to be a dependent event, so you better watch what your second probability comes out to be. Okay.